Good morning students, this is Latif sir. In this video I am going to start the 6th chapter of class 12 chemistry. The topic is general principle and processes of isolation of elements. That is this chapter is actually metallurgy. In this chapter I will discuss how to extract metal from its ores, how to purify, how to refine a metal. Okay. So first you have to know some definition like what is metallurgy. It is the scientific and technological process. Scientific and technological process used for isolation of metal from its ore is known as metallurgy. Okay. And next definition is gangue. What is gangue? The earthly undesirable material, that is impurities which are contaminated with the ore are called gangue. And next definition is next term is minerals. What are minerals? They are naturally occurring chemical substances. Naturally occurring chemical substances in the earth crust obtainable by mining, and metals are present within minerals with some impurities. And ores. What are ores? The minerals from which metals can be economically and conveniently extracted is called an ore. So from ore is a mineral, and from ore you can extract metal economically at low cost and conveniently. Okay, so in this chapter you have to read about the extraction of four metals according to the syllabus: iron, copper, zinc and silver. Okay, about this four, aluminum is not given in the syllabus. Okay, so iron, copper, zinc and silver, you have to read about this, only about these four metals: iron, copper, zinc and silver. Okay, so first you have to know what are the different ores of iron, copper, zinc and silver. I have told that aluminum is not given in the syllabus, so aluminum not required. Ore of iron, there are different ores of iron are given here. You can see hematite, magnetite, siderite, iron pyrites. Hematite is Fe2O3, magnetite is Fe3O4, siderite is FeCO3 and iron pyrite is FeS2. Now see ores of copper, copper pyrites, that is CuFeS2, malachite, that is CuCO3, CuOH whole twice, cuprite, Cu2O, copper glans, that is Cu2S. These are ores of copper. And ores of zinc, zinc blend, that is ZnS, calamine, ZnCO3, zincite, ZnO. And ore of silver, here it is not given, I am writing what is the ore of silver. Ore of silver is silver glans. Okay, so silver glans is formula is silver sulfide, Ag2S. Okay, so you have to remember the different ores of silver, zinc, copper and iron, only these four metals. Okay, and now see extraction and isolation of metal from its ore. Extraction and isolation of metal from its ore involves the following major steps. First step, concentration of ore. Second, converting the ore into oxide. And the third step, that is main step of which is reduction of metal oxide into metal. And last step, refining of metal, purification of metal. So these are main four steps for extraction and isolation of metal from its ore. Okay, so first step is concentration of ore, or it is also known as dressing of or benefaction. Okay, so concentration, in simple word, concentration of ore means removal of unwanted materials from the ore. Okay, unwanted materials like sand, clay, etc. from the ore is known as concentration or dressing or benefaction of ore. And there are different method of concentration of ore, and these are hydraulic washing, magnetic separation, leaching, froth flotation, and leaching is not given in the syllabus, okay, according to the reduced syllabus. So first method of concentration, that is first method of removal of unwanted impurity from ore is, first method is hydraulic washing or gravity separation. What is the principle of this method? Gravity separation, hydraulic washing or gravity separation. The principle of this method, this is based on difference in gravity. This is based on the difference in gravity of the ore and the gangue particles. In this process, an upward stream of running water is used to wash the powdered ore. The lighter gangue particles are washed away and the heavier ores are left behind. This is the technique of removing unwanted impurities using this method. In this method, an upward stream of running water is used to wash the powdered ore, okay, and the lighter gangue particles are washed away and the heavier ores are left behind. And this method is frequently used when the ore particles are heavier than the earthly or rocky gangue particles, okay. And this method is commonly used for oxide ores such as for hematite, tin stone, okay, and for native ores of gold and silver. Next method of concentration is magnetic separation. Magnetic separation, what is the principle of this method? This is based on difference in magnetic property of the ore component. Difference in magnetic property, this is the differentiating principle of magnetic separation. The principle of magnetic separation, this is based on difference in magnetic property of ore components, that is ore and gangue, okay. So if either ore or the gangue, any one of these two is capable of being attracted by magnetic field, then such separation is carried out. The ground or powdered ore is carried on a conveyor belt which passes over a magnetic roller. The magnetic particles form a separate heap near the magnetic roller, okay. Using this method, magnetic separation, iron ores such as hematite, magnetite, concentrated by magnetic separation. And next I have told that leaching is not given. Leaching, this is actually chemical method of concentration. Leaching is not given, okay. And leaching of aluminium, it is also not given. It is actually applicable for concentration of ore of bauxite, that is alumina. Leaching of alumina from bauxite, it is not given. Alumina is not given. Aluminium is not in the syllabus, okay. But you have to read the leaching of gold and silver. This is actually the method of extraction of gold and silver. Silver is given in the syllabus, gold is not given, okay. So you have to read the leaching of silver. This is the actual extraction method of silver, okay. That is leaching, that is chemical method of concentration. So using leaching method, you can extract silver from its ore, okay. In metallurgy, the silver and that of gold, in metallurgy of silver and gold is not given in the syllabus, gold not required, okay. Silver you have to read. Silver, in the metallurgy of silver, the silver is leached with dilute solution of NaCN and KCN. Silver is treated with NaCN and KCN in presence of air, and silver forms uh, in presence of air, from which the silver is obtained later by replacement with another metal, okay. So in the extraction metallurgy of silver, first silver and gold is not required. This is known as MacArthur forest cyanide process. MacArthur forest cyanide process. In this method, silver or gold, which is generally written M, as M means silver or Ag or Au. Au is not required. You have to read about only about silver. So silver is treated with NaCN or KCN, that is Cn minus ion. So 4m, that is 4 Ag plus 8 Cn minus plus water plus O2, it forms a complex compound 4 AgCN whole twice. Okay, plus 4 OH minus, her M is Ag I have told. Okay, and next step this complex compound, that is AgCN whole twice minus AgCN whole twice minus, is treated with another metal, and another reactive metal. Zinc displaces silver from this complex compound and it forms ZnCN whole 4 2 minus an Ag metal. You will get, finally you will get Ag metal, silver metal. So using leaching method you can extract silver and gold metal. Okay, in this method silver is leached with silver is treated with dilute solution of KCN and or NaCN in presence of O2. First silver forms uh, complex coercion complex with cyanide KCN and NaCN, leaving behind the impurities. Okay, and then in next step this complex compound is treated with a reactive metal like zinc, and zinc displaces silver from this complex compound, and finally you will get silver metal. Okay, now see what is the role of NaCN or KCN in extraction of gold and silver. What is the role of NaCN in extraction of gold and silver? Gold is not required, only you have to read about silver. So in metallurgy of silver, the respective metal is reached with dilute NaCl. Okay, now next method of concentration is froth flotation method, important method. It is actually applicable for sulfide ore like zinc sulfide, copper sulfide. Okay, so froth flotation principle of this method, the mineral particles are weighted by oil. The mineral particles are weighted by oil, while the gangue particles are weighted by water. The mineral or ore particles are weighted by oil, while the gangue particles are weighted by water. And this method has been used for the removing of gangue particle from sulfide ore. So froth flotation, this method is usually used for sulfide ore. Okay, and in this process a suspension of powdered ore is made with water. To it collector and froth stabilizer are added. Okay, so collectors such as which collectors are used? Collectors such as pine oil, fatty acid, xanthate, etc. used to enhance non-weightability of the mineral particles. Okay, and froth stabilizer like cresol, aniline, etc. are used to stabilize the froth. And the mineral particles are weighted by pine oil. The mineral particles are weighted by pine oil, while the gangue particles are weighted by water. A rotating paddle agitates the mixture and draws air in it. As a result, the froth is formed, which carries the mineral particles, and the froth is light and is skimmed off, and it is then dried for recovery of the ore particles. Okay, so in this froth flotation, the role of this depressant, sometimes depressants also used. Depressants are also used in froth flotation method. Okay, when two or more different sulfide ore are present, then you have to use a depressant. Okay, so depressant selectively prevent one of the sulfide ore. Depressant selectively prevent one of the sulfide ore coming uh, coming to froth by complexation. Okay, so NaCN is used as depressant. NaCN is used as depressant when ore containing zinc sulfide and lead sulfide. NaCN selectively prevents zinc sulfide from coming to the froth but allows lead sulfide to come with the froth. Okay, So you have to remember the role of depression in froth flotation method. Now see, next topic is extraction of crude metal from concentrated ore. After concentration, you have to convert the concentrated ore into oxide form. Okay, to make the concentrated ore into oxide form, you have to do you have to uh, you have to do two simple process. One is known as calcination, another is known as roasting. Okay. So what is calcination? Calcination is a process. Calcination is a process of heating ore strongly either in limited supply of air or in absence of air. You have to, after concentration of metal ore, uh, you have to convert the metal ore into oxide form by heating the metal in presence of air. So calcination, it is the process of heating the ore strongly either in a limited supply of air or in absence of air. Okay. So during this process, following changes take place, like volatile matter is removed, moisture is removed from the ore, water from the hydrated oxide is removed, the ore become porous. Okay, for example, carbonate ore when heated in absence or in limited supply of air, carbonate ore decompose to its oxide, like uh, ZnCO3. ZnCO3 when heated below its boiling point, it converted into zinc oxide and carbon dioxide. Calcium carbonate, magnesium carbonate when heated, it converted into CaO, MgO and carbon dioxide. Similarly, when Fe2O3 iron oxide dot XH2 hematite is heated, you will get Fe2O3 and XOH2. So water, vapor, carbon dioxide, all these gases will be removed on heating after calcination. Okay, and roasting, similar process. Roasting is the process of heating the ore strongly in presence of excess air or regular supply of air. Okay, so in roasting, you have to heat the metal ore, concentrated metal ore, in presence of excess air in a furnace at temperature below its melting point. Okay, and this method is generally used for sulfide ore. Roasting is generally used for sulfide ore, and calcination is generally used for carbonates ore. Okay, and hydrated ores. For example, during roasting of zinc sulfide is heated with oxygen and it is converted into zinc oxide and sulfur dioxide gas. Similarly, lead sulfide is heated, it converted into lead oxide and sulfur dioxide gas in presence of oxygen. Okay, and the next step of extraction of metal, which is most important, is reduction of metal oxide. uh, after calcination and roasting, the metal ore converted into oxide form, and at the next step you have to convert the metal oxide into metal. Okay, so this is known as reduction of metal oxide into metal. So reduction of metal oxide usually involve heating the metal oxide with some other substances, and these are known as reducing agent. You have to heat the metal oxide with a reducing agent, and reducing agent are generally carbon or carbon monoxide, or even another metal is also used as reducing agent. Okay, so in reducing process, metal oxide like MXOY, reducing agent like carbon, when the metal oxide is heated with carbon metal oxide, the formula is MXOY. This general metal oxide MXOY, when heated with carbons, it converted into metal and carbon monoxide. Okay, so during the reduction, the oxide of metal decompose to give metal and oxygen. So the main step of extraction of metal is reduction. In this step, metal oxide is converted into metal, and for this you have to heat the metal oxide with a reducing agent. So this is thermal reduction. Okay, so some metals get reduced easily, and while others are very difficult to reduce. Reduction means electron gain. In any case, heating is required. Okay, so now see, after reduction you will get the metal, crude metal, which is impure metal. Then after reduction you have to refine the metal. Huh. After reduction you will get metal from metal oxide, metal ore, and after getting metal from the metal ore, after reduction you have to do the refining of the metal. Okay, here one question is given: how are gold and silver are extracted? So according to syllabus only extraction of silver you have to read, gold is not required. Okay, silver you have to read only. So silver extracted by leaching the metal with NaCN, I have told already, and the metal is recovered later recovered by displacement method, in which zinc act as reducing agent. Okay, so in first step silver is treated with KCN and NaCN, and it forms a complex compound, and next step you have to react the complex compound with zinc metal. Zinc metal displaces silver from this AgCN whole 4 compound. Okay, and finally you will get silver metal. So last step of this metal extraction is refining. Last step. Okay, so a metal extracted by any method is usually contaminated with some impurities, and the process of obtaining high pure metal from impure metal is known as refining. Okay, so there are different method of refining like distillation, liquefaction, electrolysis, zone refining, vapor phase refining. Chromatography is not required. So in distillation, details of the refining method is not required, but you have to remember which metal is refined by using which process. So distillation, it is useful for low boiling metal like zinc and mercury. Distillation is used for low boiling metal like zinc and mercury. The impure metal is evaporated to obtain pure metal as distillate in distillation method. So uh, zinc and mercury metal can be refined by distillation method. Next method is liquefaction. Okay, so this method is in this method a low melting metal like tin can be made to flow on a sloping surface at high temperature, and in this way it is separated from higher melting impurities. Electrolytic refining important. Using this method copper metal is refined. Okay, so the impure metal uh, act as anode. In this method you have to take the impure metal in electrolytic refining of a metal, generally used for refining of copper metal using electrolytic refining. In this method impure metal act as anode and pure metal act as cathode. A strip of same metal in pure form act as cathode. Okay, and they are put in a suitable electrolytic container containing soluble salt of the same metal, like if you want to refine copper metal, so you have to take copper cathode and copper anode, and you have to uh, take an electrolyte like copper sulfate CuSO4. Okay, so both cathode and anode, they are put in a suitable electrolytic bath containing soluble salt of the same metal. The more basic metal remain in the solution and less basic one go to the anode mud, and this process is also explained using the concept of electrode potential over potential and gives free energy. Okay, so during electrolysis, during refining of copper, you can follow this electrolytic refining process. Okay, so refining of copper, here it is given refining of copper. Copper is refined using the electrolytic method. It is written here. Anode is impure copper, cathode is pure copper strip. Electrolyte is acidified solution of copper sulfate. Okay, so the net result of electrolysis is the transfer of copper from from transfer of copper in pure form from anode to the cathode. So anode reaction anode anode copper from anode loses 2 electron and come into the solution, and at cathode from solution copper 2 plus ion migrates towards cathode and accept 2 electron and deposited as cathode as pure copper metal. Okay, so the impurities from the blister copper deposited as anode mud, important term, anode mud, which is obtained during refining of copper, impure copper, and anode mud is deposited at the bottom of anode. Okay, which contains antimony, selenium, tellurium, silver, gold, platinum. Some important metals are present at anode mud, in anode mud. Okay, and next method of refining is zone refining. Zone refining, this method is based on the principle of zone refining. This method is based on the principle that the impurities are more soluble in the melt than in the solid state of the metal. The impurities is more soluble in the melt than in the solid state of the metal. Okay, using this method you can uh, refine silicon, germanium, gallium. These metals can be refined using zone refining method. Okay, and next vapor phase refining using this method. uh, in this method metal is converted into volatile compound and collected elsewhere, and it is then decomposed to give pure metal. Okay, so vapor phase refining are two types. Two example of vapor phase refining is given: Mond process for refining of nickel, okay, and Van Arkel process for refining of zirconium and titanium. Just remember the term, detailed description not required. Okay, so nickel is refined by Mond process, and zirconium and titanium is refined by Van Arkel process, and chromatographic method is not required. Okay, and next day I'll discuss about extraction of defined metals. Okay, thank you students.